3.1 works with the parabola. Okay? And we spent a lot of time doing parabola work. Okay? Standard equation for a parabola. Now, this guy, we don't spend a lot of time, what is it? H.
Isn't it h squared?
No, I know, I'm trying to think whether it's P. We use P in this course, and the other course we use H and K. So what is it? P squared and Q. Okay, same thing though.
So
Alright, it's just two different books. Alright, now, this guy here, I'm going to fall back on next year when I teach all transformations. So the first thing in grade 12 pre-calculus is you do transformations of graphs. And they're all just different graphs, and you translate them. So A, P, and Q all have an effect on what we call the standard graph for a parabola, which is y equals x squared. So do you remember how A affects the graph? What does A do to the graph?
where it opens up and down?
Whether it opens up or down. So if A is greater than 0, it opens up. If A is a value less than 0, it opens down. So there's the first thing that it does. Okay? What else does it do?
Goes left and right?
No.
Oh, yeah,
Yes.
narrow or wide.
How wide or narrow it is. Okay? If it's a fraction in front of it, it opens up wider. If it's any other value outside of between -1 and 1, it opens narrower because you times all your y values. So I'll get to that. All right? P. What does P do to the graph?
Go down.
No.
Is it either y or x value?
X value. So it moves the graph left or right. So if P is positive, it moves it right. If P is negative, it moves it left. And if it's negative, then that means that value in this sign in the brackets becomes a positive. Remember, it's the opposite. So what does that leave us with Q? If Q is positive, which way does the graph move? Up. If Q is negative, which way does it move? Down. All right, so far that's what we have to have. Okay, for Rex and Shay. This is what we call a quadratic equation. This quadratic equation is y equals x squared. All right? And you guys probably should write this down. You'll have forgotten this from applied already. So let's make sure we write it down. The vertex. Vertex tells us all kinds of information. The vertex is found right here at the peak or it's found at the bottom or the top of your graph. That's where the vertex is found.
So
In this case, the vertex is 0 and 0. Okay? We'll pop back. In the case of this graph, my vertex is P and Q. Because it moves off of 0 and 0, P units left to right, Q units up or down. So that's that. So what is the other information that I can get from that vertex? Maximum or minimum value. So each one of these graphs has a maximum value or a minimum value, depending on which way it opens. If the graph opens up, that is the smallest y value possible. All the other y values are above it. That means that it is a minimum value. So that vertex is at the minimum for this graph, because all the other y values are greater than it. Okay? What else is it?
The axis of symmetry.
The axis of symmetry. This graph is symmetrical, which means it opens up exactly the same way on two sides. So if you look at that graph, it goes up like this, the same amount on the left as it does the right. The axis of symmetry refers to the line that cuts it in half and makes it symmetrical. So the equation of that line is x equals 0. In this graph, the axis of symmetry is always the equation x equals whatever the p-value is, or the x value of your vertex. Yeah, we're going to get there. Okay. The domain of this graph is always the same. What's the domain for this graph? X is an element of all reals. It goes, again, to refresh your memory. The domain is how far left does this go to how far right it goes. To write it in the other notation, negative infinity to positive infinity. Okay? The range for this graph. Y is greater than or equal to 0, where y is an element of all reals. So this graph says that it's a minimum value because all the y values are larger than that y value right there. Well, what's that y value right there? 0. Okay? So over here, your range, y is greater than or equal to q. Y is an element of all reals. All right? So this is, how low does this graph go? 0. How high does it go? To infinity. The square bracket means inclusive. The round bracket means it doesn't include. Square means it includes 0. Infinity you can never get to, so therefore it's not inclusive. So far, are you okay? Okay? Like I said, this is review for these guys. So if I get going a little bit too quick, you have to just slow down. Alright? So, let's look at example 1. I want you to write this out in your workbook. Okay. First thing that we'll do in these questions, just until we get better at it. What is my A value? What is it? -3. A value is always found in front of the brackets. What's my P value? Okay, you're on the right track, but you made the mistake that you should make. It's -4. Okay? Now, Rex, the reason it's -4 is because it's x subtract -4. That's why it changes to an add.
Oh, okay.
Okay? If it's a subtract there, it's a positive number. If it's an add there, you've subtracted a negative number. So that's, and it's important that you remember that, because everything you do left and right is going to be opposite in that bracket. Q, on the other hand, is as the sign shows, so it's plus 1. So what's the vertex for this graph? -4, 1. Very good. -4 and 1. P and Q. Since A is less than 0, which way does the graph open? Down. The equation of the axis of symmetry is how do I find my axis of symmetry? X equals the x value of the vertex. So, what's the axis of symmetry here? X is equal to -4. The axis of symmetry is an equation. When they ask for the axis of symmetry, they're not asking for the x value of the vertex, they're asking you to write it as an equation. Alright? Domain is x and element all reals. Y is less than or equal to what value? Y is less than or equal to -4 is for the axis of symmetry. So then what is 1? Okay? Alright? And the, what is it, a maximum or minimum? Maximum because it opens down. And the value is 1. Okay. Alright? Now, to graph this. So, I'm going to show you 2 ways in which they want you to graph it. One is the way we did it to begin with, so it makes it easier. The second way is actually a lot less work, but they're insistent on it. And this is where more what we're looking at in grade 12. Okay, so the equation for this graph is y equals -3 x plus 4 squared add 1. So the first thing I do is I go to my vertex. So my vertex is -4 and 1. And I know it opens down, right? Okay, so they want 2 other points, minimum 2 coordinates. So I'm going to show you how we did this last semester, and then I'll show you how you can do it this semester. So -4 and 1. So I want the x value to the left of the coordinate and the x value to the right of the coordinate. To the left is -5. To the right is -3. Okay, I know you're feverishly writing this down, but now you can just relax and watch. Alright? So now what I'm going to do is I'm going to put the x value of -5 into my equation. Okay? So -5 goes in here. What's -5 add 4? -1. What's -1 squared? 1. What's 1 times -3? -3. What's -3 add 1? -2. So the next coordinate on my graph is right there. So I'm going to do the same thing with -3. What's -3 add 4? 1. 1 squared is? 1 times -3 is? -3 add 1 is? -2. Now why did I do this? Because this graph is symmetrical. So every coordinate I go to the left or right should have the same y value. So I did it that way using that. Now they would like you to also use your y-intercept. So to do that, I'm going to put 0 in for x. Okay? So 0 plus 4 is 4. 4 squared is 16. 16 times negative 3 is negative 48. Negative 48 add 1 is negative 47. So it would be like way down here somewhere. And I have to go all the way down there. It's a poor drawing. Don't worry about it. So since... Alright. So they ask you to find 1 point. They use negative 3. So 1 point in the graph is negative 3 and negative 2. Since every parabola is symmetric about its axes, this means that another point in the graph is what? If it's symmetrical and negative 3 and negative 2, then what was the other one we found? What's the other coordinate we found in that xy? Negative 5, negative 2. That's how they got their 2 points, the same way I did. Take a value to the left of the vertex, take a value to the right of the vertex, solve for your y, and now you've got a symmetrical graph. They do sometimes use the y-intercept. I didn't need it in this case, but I found it anyways. When you graph these, you need a minimum of 3 points. 3 coordinates. And generally, you just find the vertex and 1 on each side of it. Okay? Again, I know this is a tough day, it's a tough time of day, but I need more input out of people in here. Determine a quadratic function in vertex form of the graph. I need to find in vertex form. So, if you recall, Rex, this is for you. If you had to write the equation of a line, you started by writing y equals mx plus b.
Yeah.
And then you had to find the slope and you had to find the y-intercept. Here, I write my equation as y equals a, x minus p squared add q. So that's how I start it. I need an a value, a p value, and a q value. So when I'm looking at my graph, what is my p and my q? Two and negative 3. So now I plug it into my equation. Y equals x minus 2 squared plus, subtract 3. So what's the last thing that I need to find? I need to find a. So how do I find a? Not yet. Well, it does tell you whether it's positive or negative though. How would you find a here? Okay. Rex, I'm going to use you. Y equals mx plus b. You knew y is equal to 3x plus b.
Yeah.
How would you ever find b? What did you have to do?
Isolate it.
Okay, you'd have to isolate, but what did you need before you isolated it? What did I have to put in for?
X.
And?
Y.
Y. You need to put a coordinate in, correct?
Yeah.
So why can't I do the same thing? Why can't I put a coordinate in for x and y? That's what a graph is. It's a list of coordinates. So let's pick an x and a y. Well, it looks like it crosses through what? 0 and? Negative 2. Negative 2 equals a. 0 subtract 2 squared subtract 3. I picked any coordinate that I wanted. that it goes through on this graph. All right? So I'm going to add 3 to this side. That gives me 1 equals a negative 2 squared. What is negative 2 squared? 4. I divide it to this side. What's my a value? 1/4. What's the equation of this graph? Y equals 1/4 x subtract 2 squared. Subtract 3. It's a graph. Pardon me?
How can I know y is negative 2?
All right. So far I've shown you how to get a graph, draw a graph from the equation. I've now shown you how to get the equation from a graph. 2 most important things you can do. Tell me something. Looking at that equation, what is my vertex? 2 and negative 3. Just look at the board. Don't look down. What is the equation of my axis of symmetry? Petra, what do you got?
X equals 2.
Perfect, Shay. Perfect. Okay? Is it a maximum or minimum value? Minimum. Because which way does the graph open? Up. Right? Minimum because the y value is the smallest y value on the graph. If it opens down, it's the largest y value on the graph. So that's a maximum. Okay? What's the domain for this graph? Never changes for any of them. What's the domain? X an element of all reals. That will never change. What is the range for this graph?
Y is greater than or equal to 1/4. Oh, wait. Never mind, because 1/4 is what it is. X is greater than or equal to -3.
Y is greater
You're on the right track. What is it?
Y is greater or equal to -3.
Yes. Okay? That affects the range. That affects the axis of symmetry. If you can remember those 2 things, you can't do this wrong. As long as you remember the range is affected by the Q and the axis of symmetry is affected by the P. Okay? There's one last thing I'm going to show you quickly here. And then tomorrow we'll spend the entire day just working through this section. When I look at my graph here, so I want you to follow here because they've heard this. What are these 2 values called right here? X-intercepts. Well done, Rex. They're called x-intercepts. Why? Because that's where they cross the x-axis. So they're x-intercepts. We're also going to refer to them as the zeros. Because what is the y value right there? 0. We also call them the roots. X-intercepts, zeros, and roots all mean the same thing. Where do they cross that axis? They all mean the same thing, okay? Now you have 3 possibilities. You can have 2 roots, as I do here. You can have 1 root, if the graph touched it. Or I could have no roots. Like that. Okay, those are all possibilities. Now, I told you this in applied. So now it becomes way more important now to find these with quadratic functions, we need to use factoring in order to do this. So you have to get back in touch with that. However, there is an easier way to do this. It says determine the x-intercepts of the quadratic function f of x equals 4x minus 3 squared. So if I want to find the x-intercepts, the first thing I do is make y equals 0. Alright? Now I need to solve for x. So what's the first thing I do? Divide 4 out. That gives me 0 equals x minus 3 squared. Yeah? So far so good? How do I get rid of the squared value? Square root. 0 equals x subtract 3. How do I get x by itself? X equals 3. How many roots do I have in this question? 1. Let's go back to that equation at the top there. And let's write this out. A, P, Q. What is A in this question? What is it? 4. What's my P value? Louder? 3. What's my Q value? 0. What is my vertex? 3 and 0. Is that located on the x-axis? How do I know? How do I know that it's on the x-axis?
Because y is 0.
Because y is 0. Therefore, it's on the x-axis. Therefore, this graph touches the x-axis and opens up. It only crosses it or touches it at one spot. Okay? I could have proved it both ways. But in this case, I wanted to show you that. Alright? You're going to have all the rest of today, all 7 minutes, and all of tomorrow. What you're going to find, the difference between applied and pre-calc, for those that are doing both or have done applied and doing this one, is that there'll be more problems in this one than there was in the applied. So we have to do more of that. But otherwise, the same skill set is there. So you should have no problem with this because you did it in applied. Okay? Alright. You got a few minutes just to kind of peruse through it as best you can. Maybe look at your tests again and think about correct